When you really think about it, our universe is built from these incredibly simple, non-living bits and pieces. So, the big question is, how do you get from that to all the amazing complexity we see around us? I mean, how do you get life itself? Turns out, the answer might just start with a single snowflake.
So, let's head back in time. Picture this. It's 1609, and the astronomer Johannes Kepler is on a bridge in Prague. He's watching snowflakes land on his coat, and he starts to get really fascinated. He's looking at these tiny things and wondering, why? Why do they always have this perfect six-cornered shape? And right there, in what he called a gift of almost nothing, he realized a deep, profound question was hiding in plain sight.
And get this, that question? It's basically one of the biggest questions in all of science today. Seriously, 400 years have passed, and that same curiosity Kepler had about a snowflake, well, it's the same fundamental puzzle that physicists are grappling with when they look at galaxies, at life, and yeah, even at consciousness itself.
Okay, so how do scientists even begin to tackle a puzzle this big? They use a framework, a really powerful idea called emergence. And it's this incredible concept that helps us see how all this super intricate stuff can pop up from really simple beginnings. You could even call it the secret ingredient that makes the whole so much greater than the sum of its parts. All right, so what is emergence, really? The key idea is this. It's what happens when you get a bunch of simple things together and they start interacting. Suddenly, the group starts to show off properties that none of the individual parts have on their own. It's like seeing reality on different levels.
Let me give you a classic example. You'll get it right away. Think about a bird. You could study one bird your entire life, right? Learn every single thing about its biology, its feathers, everything. But you would never be able to predict that a huge group of them can create a flock. This beautiful synchronized unit that moves and turns like it has a single mind. That flocking behavior, that's an emergent property. It doesn't exist in one bird, only in the group. And it's the same idea with something as simple as water. A single H2O molecule, well, it isn't wet. That doesn't even make sense, right? The property of wetness only shows up, it only emerges when you have a massive, massive collection of those molecules all interacting with each other. Again, it's a quality of the whole, not the tiny little part. So if flocks and wetness are emergent, this brings us to what might just be the most profound, the most complex, and honestly the most mysterious emergent phenomena we know of in the entire universe. And that's consciousness. The feeling of being you.
And here is the absolute heart of the problem. Your brain, right now, is made of billions and billions of neurons. And individually, they're just little biological machines. They're following simple rules. They're not aware of anything. So how? How does that rich inner world you're experiencing, the feeling of being I, just arise from all that mindless activity?
Well, to even begin to find an answer, we've got to look somewhere really interesting. We're going to turn to a classic cult book that did something amazing. It connected the work of an artist, a musician, and a mathematician, people who seemed totally unrelated. And the connection between them, well, it offers a pretty stunning clue.
Right. So that clue comes from this fantastic book by Douglas Hofstadter called Gödel, Escher, Bach. He came up with this idea that consciousness is something he called a strange loop. And honestly, there is no better way to picture what he means than M.C. Escher's mind-bending drawing of two hands, where each one is literally drawing the other into existence.
Okay, so what on earth is a strange loop? Well, think of it like this. It's a system where you can move up or down through different levels, say from the real world to a represented world, like a drawing. And then, paradoxically, you wind up right back where you started. It's totally self-referential, a complete paradox.
Let's break it down. First, you've got a system with different levels of reality. Think about the hand holding the pencil versus the hand being drawn. They're not the same, right? Then, some kind of process moves you from one level to the next. But here's the crazy twist. The lower level, the drawing, somehow turns back and affects the higher level, the drawer. And boom, you've got this closed, paradoxical loop. All right, I know what you're thinking. This is a cool, abstract idea. But what does it have to do with consciousness? Well, the theory proposes that our own sense of self, that feeling of I, is one of these strange loops, and it's running on the hardware of our brain.
Now, the key piece of the puzzle here actually came from a mathematician named Kurt Gödel. Way back in 1931, he did something incredible. He proved that a formal system, like mathematics, was complex enough to make true statements about itself. This idea of a system referring to itself was absolutely revolutionary.
So fast forward a few decades, and Hofstadter makes this brilliant leap. He basically said, hey, wait a minute, just like math can refer to itself, maybe the human brain is a biological system that has finally become complex enough to build a symbol or a model of itself right inside its own network.
And that, right there, is the heart of the whole idea. The feeling that we call I is that symbol. It's the model of the self that the brain creates. So consciousness isn't some extra thing, it's the very experience of this strange loop in action. It's the brain observing its own model of itself, which is, in turn, observing the brain. It's a loop.
Now, what's so powerful about this perspective is that it stops treating consciousness like some magical ghost in the machine. Instead, it frames our sense of self as something that was almost inevitable, an emergent property that just happens when a system gets complex enough to start referring to itself.
So, let's just recap for a second. We started with emergence, this cool principle that explains how you get amazing complexity from simple rules, and we pegged consciousness as maybe the ultimate example of that. Then we dove into this idea of the strange loop, a system that can look back and refer to itself, and saw how it could be a powerful model for how our own sense of I actually comes to be.
And all of this leaves us with one final, fascinating, and maybe even a little bit unsettling thought. If our sense of self, our consciousness, is fundamentally a pattern, a kind of computational loop running on our neurons, what does that mean for the future? Does that mean that true artificial consciousness isn't just possible, but maybe it's inevitable? Are we, right now, on the verge of programming another conscious mind?